All right, today we're going to go ahead and do lesson 2 of matrices. If you haven't already done the bell work, will you go ahead and hit pause on the video and try the bell work on your own? All right, so hopefully you've done that. So as we go over this together, first we want to find the dimensions of a matrix. Remember, the first thing we want to do is we want to find the rows, and then we want to find the columns. So this would be a 1 by 4, B would be a 2 by 2, and C would be a 3 by 4. Similarly, when we're talking about elements of a matrix, if I have K2, 3, it means I go second row, third column, which is 4. K3, 2 means third row, second column, which is -4. For 3, when we're looking at this, we want to solve for m and n. Remember, we can make a system of equations because these two numbers would equal each other and these would equal each other. So I'm going to go ahead and write this out. So I'd have m plus n equals 9, and I'd have 2n minus 1 equals 7. I can actually just solve the bottom one, so I'm going to add 1 to both sides to get 2n equals 8. Divide both sides by 2, leaving me with n equals 4. I'm going to plug that back into the top equation, so I get m plus 4 equals 9. Subtract 4 from both sides, leaving me with m equals 5. Then for this last one on the bell work with number 4, I'm going to go ahead and I want to combine -3b plus 6c. So the first thing I'm going to do is I'm going to multiply my first matrix by -3 to get -6, -18, 0, -3, -9, 6, plus I'm going to multiply the second one by 6 to get me 30 plus 42. Or not plus, sorry, just 42, not plus 42. And then 6 times -2 is -12. 6 times 4 is 24. 6 times 5 is going to be 30. So I can go ahead and add those together. When I do that, I get 24, 24, 30, -15, 15, and 36. Once you have that done, let's go ahead and let's go to the next page. Okay, so when we're talking about, or what we're talking about today is multiplying two matrices together, and it was actually introduced by this English mathematician. His name was Arthur Calais, and he actually determined that we can use this process to be able to solve systems of equations. And so the method of multiplication of matrices is not as intuitive as last time. So we can see, for example, last time when we added things together, we just went top left corner plus top left corner, top right plus top right, and that's not going to be the case this time. So for us to be able to understand matrix multiplication, we're going to be introduced it below. So this is what it's going to look like. When we're writing, or when we're looking at this, what we do is we go every row times every column in the matrix. So we can see, and how we're going to do that is we go this first element times this first element. So first element in the row times the first element in the column, and that goes right here. Second element in the row, second element in the column, that's what goes right here. Plus the third in the third, which is right here. And then last, we do the same thing with the fourth and the fourth right here. We then add these together to simplify it to be 70. So doing the same thing down here, we can see this application as we have this car dealership that sells 4 different types of models, A, B, C, and D on a given week. And this dealer sold 10 of car models A, 5 of B, 8 of C, and 3 of D. And we see the selling prices are represented as $12.50, $11.80, $15.90, and $25.30. This, we can see they've actually given to us in a matrix, and we want to find the total revenue, and we can do that by multiplying the matrices together. So what I'm going to do is I'm going to go first element in the column times the first element in the row, meaning I have 10 times 12,500 plus, now to follow that same pattern, I've got second and second, so that's 5 times 11,800 plus, now I go third and third, it's 8 times 15,900 plus, and then 3 times this last one, so 3 times 25,300. So when I simplify that and put it in a calculator, I see that my total revenue was $387,100. So that's the very introduction of matrix multiplication. What it's going to look like is the following. The first thing that's the most important is we have to pay attention to dimensions of matrices. When we're paying attention to these dimensions, we can see, for example, if the matrix A has the dimensions 1 by 3 and B has the dimensions 3 by 1, because the dimensions in the middle are the same, that means we can multiply them and the resulting matrix will be whatever's on the outside, so it'll be a 1 by 1. Similarly, we can see that's what it did right here. Similarly with this one, if we have a 2 by 3 and a 3 by 2, since the 3 and the 3 match right here, that means that we can multiply them and our resulting matrix will be a 2 by 2 matrix, which is what we wrote right here. Now, why this has to be the case is the following. Remember that it's row times column. Well, we can see in this case, if we did 4, we'd go 4 times 3. We'd go 5 times 7, but then 6 wouldn't have anything to multiply. So that's why it's not possible. So we can see, for example, with these two matrices over here, matrices on the right, that we've got a 1 right here and a 4 right here. So because of that, they're not possible. And this one has a 2 right here and a 6 right here, so that is not possible. So if we look at this, we just want to determine if they would be defined if we multiplied them, and if they were, what the resulting matrix dimensions would be. So we see that we have this is a 2 2's in the middle, so it would result in that it would work, and we would be left with a 3 by 1 matrix. Here we see we have a 3 and a 1 in the middle, so it's not defined, so this one wouldn't work. And then this last one, we see that this is a 1 and a 1 in the middle, so this would work, and it would result in a 4 by 6 matrix. Okay, how we multiply these is the following. Again, we've already talked about this multiple times, but we would multiply everything in the first row by everything in the first column. So if we think about this, we would think about this is this would be then in C, everything's in row 1 and everything's in column 1, so it goes in C1 1, which is this right here. So similarly, if we were like to go row 2 and column 2, that means this would be C2 2, meaning that this would go in this middle spot right here, and so on and so on. So let's see how this works as if we go to the next page. So the first thing we want to do is we want to determine if we can multiply these. We can see that with this first matrix, this is a 2 by 2 matrix, and the second one is a 2 by 2 matrix. Since the two numbers in the middle are the same, it'll work. We take the outside numbers to see the resulting matrix, which will be a 2 by 2. How we will do this, I am going to go row 1 times column 1. So I'm going to write this as -3 times 1 plus 4 times 2, and that's the element that goes in 1 1. Now I'm going to do the same thing, but now it's going to be this same row up on top, but now it's going to be this column on the right. So I'm going to write this as -3 times 0 plus 4 times -3. Now we're going to do the same thing with the bottom, but this time, or same thing, but now it's going to be the bottom. So I'm going to go this second row times this first column. So I'm going to go 5 times 1. Then I go plus 2 times 2. And for this last one, I do that that second row times this last column, resulting me in 5 times 0 plus 2 times -3. We can then go ahead and simplify this. So when I simplify this, I'm going to get this to be 5 -12, 9, and -6. And that's how we multiply matrices together. So let's go ahead and let's look at this next one. If we're looking at this, we can see that these are both 2 by 2's, so they can be multiplied and they'll result in a 2 by 2 matrix. So we can go ahead and start multiplying these. So I'm going to go first row times first column, which gets me 7 times 7, which is 49, plus 3 times 8, which is 24. I'm going to keep the same row, but do the next column. So I'm going to go 7 times 4, which is 28, 3 times 1, which is 3. Then I'm going to do the second row times the first column. So that means I'm going to get 14 plus 5 times 8, which is 40. Then last one, I'm going to do last row times second column. So I go 2 times 4, which is 8, plus 5 times 1, which is 5. I can then go ahead and simplify this. So I'm going to add the numbers together to get 73. Okay, sorry about that. So that means that this would result in, this would be 73, 31, 54, and 13. All right, will you go ahead, will you hit pause on this video and will you just try number 4 on your own? So hit pause for a moment and try number 4 on your own. Okay, if we're looking at this, we can see that this is a 2 by 3 matrix and this is a 3 by 2 matrix. Since these two numbers match in the middle, this means that we can multiply it and the resulting matrix will be a 2 by 2 matrix. If we want to be able to write this out, what we're going to do is we're going to do row times column. So I go first row times first column. So that means I go 1 times 4, which is 4, 2 times 6, which is 12, 3 times 5, which is 15. First row times second column. So I go 1 times 8, which is 8, 2 times 2, which is 4, 3 times 3, which is 9. Now we're going to move on to the bottom rows. So I'm going to do the bottom row in the first column. So I get 4 times 4, which is 16, 2 times 6, which is 12, 7 times 5, which is 35. Then I'm going to do the last row in second column, which gets me 32 plus 4 plus 21. I can then go ahead and simplify them. So I get 31, 21, 63, and 57. Okay, this last one is personally my favorite. If you look at this matrix over here on this right-hand side, we actually call this the identity matrix. And the cool thing about the identity matrix is whatever we multiply with the identity matrix, it's actually just going to give us this original matrix. We could see this because if we did this, for example, it's row times column, right? So we go 1 times 1, which is 1. Then we would go 4 times 0, which is 0, and 6 times 0, which is also 0. So 1 stays the same. So now we're going to do the same thing, but we go the same row times the next column. So I go 1 times 0, which is 0. 4 times 1, which then that means I get 4, and then 6 times 0, which still keeps me 0. Doing the same thing with that last one, I go 1 times 0, which is 0, 4 times 0, which is 0, and then 6 times 1, which is 6. So basically, this identity matrix is the same thing, or it's equivalent to whenever we multiply by 1. Like if we did 6 times 1, we get 6. It's the same thing, but it's in the matrix form. This next concept is something that is not very intuitive and something, again, that kind of goes against what we're used to being told, is that when we are multiplying matrices, order really matters. AB is not the same thing as BA. And we can see that right here. If we took these two matrices and we multiplied them together, this means I would have 1, 2, 3, 4 times the matrix 5, 6, 7, 8. When I multiply those together, I'm going to get 19, 22, 43, 50. Where when I go B times A, this time I have, oops, not 6. I have 5, 6, 7, 8, and 1, 2, 3, 4. When I multiply these together, I then get 23, 34, 31, 46. So I can see that with these multiplying together, I actually got different results, or I got different answers, so they don't always work. All right, so what I want you to do is I want you to take a minute. Will you just try 7? See if you can find CD and find DC. All right, so hopefully you took a moment and tried to figure those out. Let's go ahead and figure these out together. So if we look at this, if we go C times D, that means we have a 2 by 3 times a 3 by 2, which means our resulting matrix is a 2 by 2. So how I'm going to write this out is I'm going to go this first row times this first column. So I go 3 times 1, which is 3, plus 1 times 3, which is 3, plus -1 times -2, which is 2. Now I go first row times second column. So I go 3 times 6, which is 18. 1 times -5, which is -5. And -1 times 4, which is -4. Now we're going to do second row times first column. So 2 times 1, which is 2. 0 times 3, which is 0. And 3 times -2, which is -6. Now doing this one last time, bottom row times second column, I get 2 times 6, which is 12, 0 times -5, which is 0, 3 times 4, which is 12. I can go ahead and I can simplify this, so when I simplify it, I'm going to get 8, 9, -4, and 24. So now we're going to do the same thing, but now it's D times C. This means that I have a 3 by 2 and I'm multiplying it by a 2 by 3. So my resulting matrix is going to be a 3 by 3 matrix. To make sure I don't get confused, I'm going to rewrite C over here on this right hand side. So I'm going to write 3, 1, -1, 2, 0, 3. I'm going to go ahead and I'm going to go row times column. So this for first row times this first column, which when I do that is 1 times 3, which is 3, and 6 times 2, which is 12. Then I'm going to do the same row times that next column, so I go 1 times 1, which is 1, 6 times 0, which is 0. Then last one, I go this top row times the far right column, so 1 times -1 is -1, 6 times 3 is 18. Now we're going to do the same thing with the second and third rows. So I go 3 times 3, which is 9, -5 times 2, which is -10, 3 times 1, which is 3, -5 times 0, which is 0. Then for the last one, I have 3 times -1, which is -3, -5 times 3, which is -15. Then we're going to do that with the last row. -2 times 3 is -6, 4 times 2 is 8, -2 times 1 is -2, 4 times 0 is 0, -2 times -1 is 3, 4 times 3 is 12. I just messed that up, sorry. That should have been -2 times -1, which is 2, and then that should have been 4 times 3, which is 12. I can then go ahead and simplify this. So when I simplify it, I get this to be 15, 1, 17, -1, 3, -18, 2, -2, and 14. Okay. Now, we do have instances where we use matrix multiplication in word problems. So, for example, if we're a business owner and we're selling clothes, we can see that the following two represent items sold on both on Monday and a Tuesday. So how I'm going to write this out is I'm going to first write a matrix with the money, and I want them to be able to be multiplied together. So I'm going to write this as a 1 by 3. So that means that I can see that the prices are 10, 15, and 20. So I'm just going to write that as 10, 15, and 20. Then I'm going to write the next one as a 3 by 2 with the 2 different days. So on Monday, I sold 3 t-shirts, I sold 4 hats, and 1 pair of shorts. On Tuesday, I sold 4 t-shirts, 2 hats, and 3 pairs of shorts. I'm going to go ahead and multiply those together. Remember, we go row times column. So when I'm looking at this, I'm going to shift all this over so I've got room. I'm going to go ahead and go 10 times 3, which is 30, 15 times 4, which is 60, and 20 times 1, which is 20. Then for my next one, I'm going to go 10 times 4, which is 40, 15 times 2, which is 30, and 20 times 3, which is 60. To go ahead and simplify this, I'm going to combine, and I get 110 and then 130, which means if we wanted to determine the total revenue over both days, we could actually just add those together, and we could write this as $240. Okay, this last one right here, this is similar to what we were talking about yesterday when we were talking about creating a system of equations. We're going to do the same thing here. We're going to create a system of equations. This time, however, we're going to do it because we're going to go row times this column for one equation, and that should equal 17. Then to create another one, we're going to go this row times this column, and it should equal 9. So I go x times 1, which is x, y times 3, which is 3y, and this should equal 17. Now we're going to do row times column again. So I go x times negative 1, which is negative x, y times 2, which is 2y, and this should equal 8. From here, what I can see is I actually already have opposite coefficients, so I can add them together to get 5y equals 25. Divide both sides by 5, and I am left with y equals 5. From here, then I can go ahead and plug it in. I'm going to plug it into the top one, so I have x plus 3 times 5 equals 17, which when simplified is x plus 15 equals 17. Subtracting the 15 from both sides, I'm left with x equals 2. So we can go ahead and see that x equals 2 and y equals 5. So that is multiplying matrices. So go ahead and try the homework quiz on your own. If you have any questions, let me know.